My story starts as a tale of many hats. I started this company called Wank 5 years ago. And yeah, back then it was all about like starting your company, so creating value for your customers or the people you're at least trying to attract. And the whole idea of automating ops and automating deployments, well, it didn't bring value to the customer, so we didn't put many effort into that. So to start out, just a little bit of a background, so it will turn into my story here. I'm not going to make too much of advertising, but basically what Wank does is you give us a URL and we go on many different sources, being your website, being third-party services we use, get information about your website and try to give you feedback and actionable tips on how you can improve your website to get it moving on Google, on social media, and so on and so forth. So in the end, we give you a final score based on how well you're doing. So this tool, as I said, was we started this a little over 4 years, almost 5 years ago. And when we did this, we kind of hit a nerve, I guess, because quite soon we were tech crunched, as they call it. Back then it was really cool. I don't know the state of TechCrunch today anymore. I'm not up to date with those things, but they attracted lots and lots of visitors worldwide, and they even asked us like, okay, we're gonna break the story about you, but are you ready to do this? And well, I said, well, we're on AWS, auto scaling and all of those things. What could possibly go wrong? Well. Things went wrong because the amount of visits was so huge within a flash that we went down. What we did was, okay, get a bigger server, bigger instance at AWS. Site went obviously down again, and it was this whole dance of getting bigger servers. And in the end, we more or less found a way to keep it back up, because I think this is a picture I took from the web archive. I think there were many updates like that until they finally said, okay, if you don't fix it right now, we're gonna throw you off. So quite soon, or at least initially, I was just a pure developer writing code, and ops I didn't think shouldn't have been my problem because we were on AWS, but quite soon it became my problem. So what we did after this, let's call it experiment, was instead of keeping our tool, so our program, as one big monolith, is thinking, okay, we call so many different services. Some of them are slow, some are fast. I mean, there was so much things going on, so we needed to extract them from each other. And also then, I don't know if microservices was already like this big hype term, but yeah, this is the way we intended to build our application. Like, okay, the logical parts that belong together, that have one particular job to do, let's just separate them from the rest, so they can also have their own database based on the use case we're trying to solve. And basically that's how we started rebuilding the tool from quite early, and that's how we still do it today. Like now here I listed 4, but I mean right now it's probably 50 different applications that create Wank, let's say. But the whole story of microservices is I mean, it's good, it helped us a lot, but it's also not a free meal. Like, it's not gonna suddenly solve all of our problems, or at least there are other issues, even when working with microservices, that you need to solve. And one of the biggest ones is version drift, meaning, and I kind of depicted it in a little table over here. I think everyone can sort of relate to this thing. Like, you have 3 environments, your local machine, you have a test environment, and a production environment that all need to run a certain programming language or databases or whatnot. And keeping those versions in sync with each other is really a daunting task, especially when you don't have someone yeah, dedicated to ops, or that's really fluent with ops. Also config management, like Puppet, Chef, and or Ansible. Yeah, 4 years ago weren't that big yet, or at least we hadn't discovered them yet. So this was a big problem even when implementing microservices. So okay, I started thinking, how can we solve this? And this is a problem many people have, and there's a simple solution to that, naming these virtual machines. So we all installed Vagrant on our local boxes, and on AWS you have this nice system of AMI, so images you can bake out of everything. So that was sort of a solution to the problem, but still it was slow. Like downloading operating system virtual boxes was very slow. Deploying to tests and production needed builds of those images, and they are slow. Sometimes we had the issue, or just in general had the issue of golden images, like you install new things on your servers, bake images, but in the end you don't know anymore what you did in the beginning, so not that great neither. And also, yeah, when you want to run an application and you want to run it, quite safely, you don't want it on just one server, you want more servers. So an application was being load balanced between 2, 3, up to 10 servers that actually weren't needed. At least the computing power wasn't needed, but we wanted this redundancy. Like if one thing goes wrong and it takes 2 servers out, at least we still have a few running to keep the application up. But we were over provisioning, so paying for things we weren't actually using. So yeah, this is just a diagram of what virtualization means. So like you have one piece of hardware on which you install many different operating systems, and they're virtualized. They're all in their same in their own space, so they cannot interfere with each other on the file system level. Obviously, there's always the problem of noisy neighbors, where when one virtual system uses too much CPU, the other can feel that. And again, in general, like if we see how microservices were running in our environments, there's a lot of service discovery needed. Obviously, like applications want to talk to each other, want to share data, and need to find each other. So this is really one of the biggest problems. And taking matters worse is okay, that was the production environment, but there's obviously a test environment that sort of needs the same setup. Same for your development environments, so on and so forth. So this is another thing that like we stumbled upon many times, like, well, it worked on my machine and now I pushed it to production, so not my problem anymore. So another thing we needed to solve. So in general, what we were looking for, like the driver of our quest to get a better system, was something that was, as the very first, simple. So it's something that everyone could understand, and not even developers. Like everyone in the company at least had a general idea of, okay, what are these guys using? So something we could easily explain to everyone and easily implement. Another thing, obviously, one that already was solved by virtual machines, is it should be isolated. So we should be able to run applications next to each other on the same infrastructure, but they shouldn't interfere on an operating system level with each other. It needs to be portable. I need to be able to run my application on my local machine, but I want to run that same application in my test environment, in AWS, maybe on bare metal if we decide to get a few servers somewhere co-located. So it needs to be portable. Also needs to be automated. Like I said in the beginning, you didn't care that much about automation, but you start doing things and in the end you don't know anymore what you did in the beginning. So we wanted something that can be automated, that we can put in a CI/CD, like continuous deployment pipeline, and that can run automatically. As soon as a new feature is pushed, it should be able to go in production almost automatically without interference of a human being. Flexible. So as I said, virtual machines are kind of heavy. Like a VM could easily be a few hundred megabytes that you always have to pull into your machine. So it's not very flexible. It needs to be something easier to use. And finally, something or one other thing we wanted is that it needs to be able to be easily versioned. If I make a change today, and tomorrow we found out it broke something, we need to be able to roll back to the day before where we knew, okay, it was working like that. And also there, just in general, it kind of already existed. Like containers isn't a new idea. It's not like Docker invented containers. They already exist for many, many years. In Linux distributions, there's BSD jails, OpenVZ, there's Chroot, so on and so forth. So it already existed, but they were still kind of operating system bound. So couldn't really use them because I'm on a Mac here. Our production and test environments are Linux boxes. So the portability and even the flexibility wasn't reassured there. So around, I guess, end of 2013, early 2014, well, actually a bit earlier, but at least that's when we discovered it. Docker came around, and they had, or their mantra was build, ship, and run any app anywhere. Meaning that if you have this table, what Docker does for you is it isolates your applications nicely away, and you can just push an application from your development machine through to your test, through to your production, and just wire in some environment variables. For instance, okay, I want to go to another database in my production environment. That's just an environment variable that you run when you start a Docker container. So if I take the same image, what Docker actually did was take the idea of containers, but also abstracted away even the operating system. So they made a nice indirection between your operating system and your applications. That's the rough idea about Docker. All right, so we arrived at Docker. Now, how does it work? So Docker, like this, kind of summarizes all the components that you have in the core of Docker. So you have a client like a CLI tool, which is in its own also an API. You have a Docker host that runs a Docker daemon that's just listening to the CLI or to the client. And at the end there you have a registry. So what happens here, and I put a big border around this because, like, let's say in 90% of the cases you'll always run the client and the daemon on the same host, but you're not forced to, so they can be separated out. Now, I'll start on the right. So what's the registry? Registry is actually a bit like, let's say, GitHub is an open source registry for, it's a registry for open source programming tools, scripts, and so on and so forth. The official Docker registry, you can also install your own, like you can install your own Git repository. But the Docker Hub, so the official one, provides you with Docker images that are provided either by official vendors, a few of them which you can see here, or you can just push your own. So I'll turn back. And yeah, we're going to see a little example in a few minutes, in a few moments. So basically what happens is when you start, or you say, okay, I want to start a Docker container on my machine, you instruct the client to run what you want to run. It will kick the Docker daemon and say, okay, I want to run this command, this application, this script, whatever. And then it will see, okay, you're asking me to run something in an Ubuntu container. I either have it cached on the Docker host or I don't, so I have to pull it from the registry. And as soon as I have that image, an image which is actually just a baked version of a container, Just like in virtual machines, you have an image of which you run a live operating system on your computer. It's the same idea here. So you run a container from an image. Okay, then I'm gonna run it as a container. So that's roughly what's going on. So been there. Yeah, and really quickly, so everything is based on Linux primitives. So when you're running Linux, no problem. You can download from apt, yum, like all the big repositories are fine, no problem. When you want to run on Mac OS X or Windows also, there's an intermediary layer which is nicely provided by Docker, by the way. So they install a very lightweight Linux virtual machine. I think it's 20, 30 megabytes big. And from there, you can instruct the client to run all the containers in this Linux virtual machine. If you go in the documentation of Docker, it's nicely explained. It's super easy to install. So nothing special you need to do there. It's just installing Docker from an official file, and that's fine. So nothing special here. Right, so we want to run our first Docker container. Very simple example here. So when you do this, you instruct the CLI, say, okay, tell the daemon to run from the Ubuntu image and let it echo hello world. So the only output you're going to get is hello world, nothing special. Why should we do that? But under the hood, there's a lot going on, right, in this command. So what's going to happen is, okay, the CLI instructs the daemon, get me my Ubuntu image, the official one in this case. It will check, okay, do I have it cached locally, yes or no? If not, I'm going to pull that Ubuntu image from the repository, from the registry, sorry. And within that container, it's going to run the command echo hello world, which then will be outputted to std out. Okay, that's pretty useless, I guess. But let's take this a little further. A couple of slides ago, I said, okay, we want to be able to first automate everything, and also secondly, be able to version things. So we need a way to describe our Docker images in a textual way. And this is the result to that, or the way you do that, in form of a Docker file. So in this case, in this example, what I want is a container that runs memcache. So I'll just go line by line. So you always have to start from a base image. So in this case, it's Ubuntu, it can be CentOS, can be Red Hat, whatever. Also, small side note, my underlying operating system doesn't have to be Ubuntu. Like you can run Ubuntu Docker images or Docker containers on a Red Hat, on a CentOS, and vice versa. So that's something you don't have to worry about. Interchanging Linux and Windows is not possible, I'd say yet, but I'm not sure if they're ever gonna be able to do that. Anyway, so side note, then I can define some environment variables in this container, or in this image, that then will run by default in the container. So I said here, okay, like it's actually just not to get, or not to ask user input when I do apt-get. Next step is a run step. So this actually tells the whole build system. So when we're gonna start building this file into an image, I'm gonna tell the build system, okay, run this command. And in this case, I say, okay, update my apt repository, and then when that's done, install memcache into it. Step further, I change the user, because especially for memcache, not every application requires this, obviously, but memcache doesn't run as root, and that's the default user when you run Docker containers. So specifically here we say, okay, run it as a different user, in this case daemon. And also, or in the next step, there's an expose saying, okay, I want this port 11211, which is the default for memcache. You can obviously change the configuration, but this is just the default set. Expose this port to the outside world, so it's possible to connect to this port into the container to give actions to my memcache. Final line is an entry point. This is basically like, okay, what's the default command that the container needs to run when I start it up. Like if I say docker run memcache or whatever name I give it, and I don't add an extra command to this CLI, then it will exactly run this. So this is like the base command of which my container will start. Right, so I had the file over there. So when I have this file and then go in my CLI, what I could do from the folder where this file is existing, say, okay, docker build, and build it with a tag, like it's under my name, and then /memcache in this folder. So this will kick off the process of going through the Docker file, seeing what it needs to do, and building the entire image. So starting from a base Ubuntu image, running the commands I told it to do, and then finally, as a final execution step, bake this into an image. So it's a bit like doing a git commit. So you made your changes and you say, okay, this is what I wanted, now I'm going to commit these changes. When that's ready, I will have an image ready that's called my name /memcache, so I can run from this. Docker run. I can start it daemonized, so without the output being open. I can give it a name, MC for memcache, and I say, okay, run it from this image. I don't provide any extra things to run, so it's going to run the entry point that we saw in the Docker file earlier. When that's running, you'll get feedback of that, obviously. When that's running, I can ask for logs, so asking, okay, everything that this container is outputting to std out, yeah, what's going on there, so you can just see the logs. I can stop it, obviously, you can start it again, or I can just throw it away. Very easy. And when I'm happy with what my container is doing, I can push it to the registry. So it can be the official registry, so I need to log in somewhere. I didn't put an example of that, so I need to log in to a certain registry. It can be my own, my private one that I run on-premise, or the official one, but at least it can be pushed to a registry where another server running Docker can pick it up then again. Other example, so memcache is my data store, let's say, or at least my in-memory states that I want to store. Now I want a node application, and I have to say it's already quite an old file. So I start from the base node image, like officially created by the Node consortium. So yeah, the version is extremely old, but anyway. Here's another line saying work there. So this is the folder under which I want to work. I add my package.json file there, and I do an npm install. So people not familiar with npm, yeah, it's like what's it called in PHP again, packages, and Python as it's. I mean, every language is a tool, but it's a library repository. So it will install my full application. Then one thing, so this is sort of a link between my what's in my folder and not yet in my image. I can say, okay, everything under the folder where I'm running my build goes into the container, or will be baked into the image actually under this folder. So it's the folder from where everything will be executed. And I can also create a mount point into the container that will link a folder on the host running the Docker container and will be mounted into the container. So files can be shared between the container and the host operating system running this. If you wanted to share like logs, for instance, I mean, there's many different or many use cases you could use this for. And then, yeah, this is similar to entry points, a bit of a detail anyway, I'm not going to go in there. And then I say, okay, start my application, and this is what it's going to do on boot. So same thing happening here. I built my image from this Docker file. I run it. So a few extra things here. So there's the name, that's the same. Run it daemonized. I link a port from the container to a port on my host machine, so I can really call on that IP of the host machine. I can mount volumes as I announce them in the Docker file. I can say, okay, on my host machine, to what's living in the container, so we can exchange. And when it's running and I'm happy with the results, I can push it to the registry. All right, that's nice and all, but yeah, now we still have these two containers and it's not really automated to run them together. So that's why Docker introduced another tool called Docker Compose, which basically gives you a YAML format in which you can define your full application. So you can say, okay, I have my memcache, I have my application container, and this is how they should work together. So all the input variables I gave on the Docker CLI are now nicely configured in here, and we can link those two containers together, so my node application can easily talk to the memcache application, and vice versa should be needed. From that, again, so that's a file also sitting in my application folder. When I run Docker Compose up, it will start both containers, make sure they run, they link together and can talk together. My application is running. Should I want to run something special in one container, I could through this command. Nothing crazy there. Another tool Docker has provided, already since a year now, I guess, is Docker Machine. So Docker in itself is nice to work with, as we've seen, and probably next speakers will show you even more about that. But obviously, I need hosts that can run Docker. Like out of the box, it's not installed. So I need to tell my machines, my local machine, my servers in test, my servers in production, to install Docker. And this is like an abstracted way of installing Docker. So Docker Machine can help you install Docker on basically at least the biggest cloud provider. So they have connections to AWS, Rackspace, DigitalOcean, probably tons of others I forget. They also have plugins to write your own. But in this way, I can instruct a machine in my cloud or even in my on-premise system to say, okay, this machine, please install Docker, and it knows what operating system is running on there, and so on and so forth. So it can really instruct that machine to install Docker, so you don't have to worry about configuration of all of that. So what it allows you to do is going from this, like you have machines, can basically be anywhere, that just run a Linux distribution, and Docker Machine will bring you in this state. So we'll make sure that every machine is ready to run Docker. Again, can be on Amazon, in Vagrant, Google Cloud, on-premise, whatever you choose. These are double slides, okay. Then final tool. So this one is called Docker Swarm. It's already a little bit more advanced. So basically what this tool allows you to do is, okay, I have all my servers that are able to run Docker, and I have my applications, but somehow, okay, I want to install them and make sure they run in test environment, in a production environment, and can find each other. This is what Docker Swarm allows you to do. So I'm not going to go too deeply into this because it's a little bit more advanced. But basically, it creates a group, and I also have a nice image for this. So it just makes a nice group of all your servers, all your instances being able to run Docker, and you can just instruct Swarm to say, okay, I have a node application that I want to run on at least 3 servers. I don't care where. I also have a memcache, so I shoot it into Swarm, and what it will do is say, okay, I run it on the resources I have available. You can add dependencies or say, okay, I strictly want it in AWS, or I strictly want it on a Europe server, so you can add tags to these things. But out of the box, this is roughly what it allows you to do. So just run your application as you described it. So just to wrap that up, it's when you have a nice system like this, it's an extremely big improvement on top of that. finishing up, so what I've seen over the past, let's say, year is that Docker has started to catch on in many companies. So in the beginning, there was a lot of talk about what Docker is, how to run your applications and workloads in Docker, then how to build services. So going further, okay, I have one application now, but how do I have many applications talking together? So that's Docker Machine and Docker Swarm. Now it's all about, okay, how do I bring this to production? How do I dump everything in my AWS, in my DigitalOcean, so on and so forth. So these are questions that are popping up right now. Then even further, okay, service discovery, orchestration, like how are they finding each other? How can they easily connect cross-host? Like if I have an application in AWS and one in DigitalOcean, how do they connect to each other? What network is there? So there's Docker has already provided network plugins for that to build overlay networks. Same for state, like DBs. Containers are not very tangible. Like you can stop it, throw it away, and it's gone. Like what if my data lives in there? I don't want it to be lost. So there's now Docker volume plugins. So third-party providers are building resilient systems to make sure that if your data lives somewhere, that it's not just gone, but the container can find it back again. And a question that basically lives all the time since the beginning and is still, I mean, it's an important question that needs improvement all the time is security and compliance. Like there are already nice tools for this, but this is something that Docker still constantly needs to improve, and chatter needs to be going on around this. Which brings me to again Docker meetup. So if you have questions about this, come see us. If you're an advanced user and want to share stories or want to help others out, come to the meetups. We're 700 members big. We've done 12 meetups in the last 18 months, I guess. We go from Antwerp, Brussels, Ghent, Hasselt. I mean, we move around. It's roughly every 10 weeks. And you can find us here. So it's on meetup.com/docker-belgium. Come and see us. And that's it for me. Thank you.